Hello students, this is Dr. Nimulakshu here. So today till date we have discussed about polar and non-polar covalent molecules. How the polarity has come to a covalent molecule and how a molecule becomes non-polar. And also we have discussed that in a covalent molecule there is some degree of ionic character is also present in covalent molecule. Okay, so now today we are going to discuss certain details of it. So now question is, if polarity comes in a molecule, then we have to measure the degree of polarity. We have to measure the degree of polarity in that covalent molecule, and to measure that certain things have to be kept in mind. So now today we will discuss the measuring the degree of polarity in a covalent molecule. How we will measure the degree of polarity in a covalent molecule. Okay. So now, degree of polarity, we know that a polar molecule is being formed by the combination of positive charge as well as negative charge. By the combination of positive charge and as well as negative charge. Thus, these molecules have two poles, and that is why they are called polar molecule. Means one positive pole and the other one is negative pole. So charges are being neutralized in the molecule. So such molecule which has got poles in it, or more precisely we can say that this molecule में polarity आएगा या two poles develop होगा, उस molecule को हम more precisely बोल सकते हैं dipolar molecule. क्या बोल सकते हैं molecule को? Dipolar molecule. Okay, so this dipolar molecule, so to how now the question is, how we will measure the degree of polarity in such dipolar molecule. So this dipolar molecule possesses one moment which is called dipole moment, and it is denoted by the symbol mu. Okay, now what is this dipole moment? Dipole moment is the product of charge and the distance between the charges, Okay, so this is what dipole moment is. Dipole moment is the product of positive or negative charges, and we can write charges and the distance between the charges. Okay, so now we can write if charge is q, so we can write mu is equal to q into d. Now we know that generally we have this q is equal to mu is equal to q into d. So we have q is equal to 10 to the power minus 10 ESU. Means what is ESU? Electrostatic unit. So we can have q is equal to 10 to the power minus 10 ESU, and the distance is d is equal to 10 to the power minus 8 centimeter. So the distance between the charges is 10 to the power minus 10 centimeter. Okay, so if mu is equal to q into d, then what power mu will come? 10 to the power minus 10 into 10 to the power minus 8 ESU centimeter. Okay, is equal to 10 to the power minus 18 ESU centimeter. Now this was being found by a famous scientist, जिसका नाम तुम लोगों ने सुना होगा, उसका नाम है डिबाई, DEBYE, डिबाई. So डिबाई ने जैसे ही ये इसको निकाला तो ये वैल्यू हो गया 1 डिवाइड, so that is mu is equal to 1 divide or 10 to the power minus 18 ESU centimeter. Okay. So now we will measure the degree of polarity. Now with this mu value we will measure the degree of polarity. So first we will take into consideration diatomic molecule. क्या लेंगे हम लोग? Diatomic molecule means the molecule which is formed of two atoms, that is the molecule which is formed of diatoms. So for example we can have HF molecule, HCl molecule, then HBr molecule, then HI molecule, like this. Okay. So first we will take diatomic molecule. Okay. Now, so first we will take diatomic molecule. Okay. Diatomic molecule. So suppose we have HF molecule. Okay. Then we have HCl molecule. Then we have HBr molecule. Then we have HI molecule. Okay. So we know that the electronegativity value of H is 2.1. Yesterday we have discussed, in our last class we have discussed. Electronegativity value of F is 4.0. Cl is 3.0. Br is 2.8. Like this way it goes. Okay. So this means that fluorine atom, chlorine atom, bromine atom और iodine atom जो भी लो तुम लोग, that is more electronegative than hydrogen. That is more electronegative than hydrogen. So what it will do? It will draw the electron pair towards itself. It will withdraw the electron pair, bonded pair of electron towards itself. Okay. As a result, it will become partial negative charge and it will become partial positive charge. Similarly, here also it will become partial positive charge and it will become partial negative charge. Okay. Now this drawing of electron towards itself has given rise to dipole moment, and this is being expressed by the symbol mu, and diagrammatically we express it like this. In this way we express it. The dipole moment is being expressed in like this symbol. Okay. So here also we have like this. Cl is drawing electron towards itself. Br is also drawing electron towards itself. So as a result, hydrogen will become partial positive charge and bromine will become partial negative charge. Similarly, Hi will draw electron towards iodine will draw electron towards itself. So hydrogen will become partial positive charge and iodine will become partial negative charge. So as a result of this, one dipole moment will develop in the molecule, and the dipole moment value for HF mu is equal to 1.78 divide, which is 1.07 divide for HCl, which is 0.79 divide for HBr, and which is 0.38 divide for HI. So we know that as we move down the group in a particular group, so the electronegativity value is decreasing. Like fluorine का कितना है electronegativity value 4.0, क्लोरीन का कितना है, क्लोरीन का 3.0, ब्रोमीन का कितना है 2.8. So it is decreasing. So as a result, the dipole moment, the electron withdrawing tendency जो है वो भी decrease होगा. Okay. So as a result क्या होगा, dipole moment value will also decrease. So we have seen that till now what we have discussed, that dipole moment value is larger in case of HF, then in case of HCl, then in case of 0.79 that is HBr, and then in case of 0.38 divide, that is in case of HI. Next we will discuss polyatomic molecules. Now what is polyatomic molecules? Means that molecules comprising of more than 2 atoms. Molecules comprising of more than 2 atoms. A very sweet example we have with us is the water molecule. जो water तुम लोग बैठ के पी रहे हो अभी, वो water molecule है very sweet example for a polar molecule and to measure the dipole moment also. Okay, so क्या होगा? Let us take polyatomic molecules. Let us take polyatomic molecules. So now what will happen? This is polyatomic molecules. Okay, so water suppose इसका फॉर्मूला है H2O, मोलिकुलर फॉर्मूला है H2O. सो इनमें से कौन सा एटॉम ज्यादा इलेक्ट्रोनेगेटिव है? डेफिनेटली ऑक्सीजन. सो ऑक्सीजन विल ड्रॉ इलेक्ट्रॉन पेयर टुवर्ड्स itself. Here also oxygen will draw electron pair towards itself, and the resultant dipole will be in this way. This is resultant dipole. This is resultant dipole. Okay. So for this oxygen में क्या होगा? डेल माइनस चार्ज डेवलप होगा, हाइड्रोजन में डेल प्लस चार्ज डेवलप होगा, here also हाइड्रोजन में डेल प्लस डेवलप होगा. So as a result, some dipole moment is coming out of it. Okay, some dipole moment is coming out of it. So the dipole moment value for water is 1.84 divide. 1.84 divide. Okay. Next we will consider another sweet example we have with us is ammonia molecule. Ammonia molecule, the molecular formula is NH3. Okay. So the ammonia molecule, what will happen here? नाइट्रोजन इज मोर इलेक्ट्रोनेगेटिव देन हाइड्रोजन. नाइट्रोजन क्या है? ज्यादा इलेक्ट्रोनेगेटिव है देन हाइड्रोजन. सो क्या करेगा वो? इट विल ड्रॉ द इलेक्ट्रॉन पेयर टुवर्ड्स itself. It will draw the electron pair towards itself. Thereby it becomes del minus and it becomes del plus. Here also del plus and here also del plus. So it will draw the electron pair towards itself. Here also the same thing will happen. तो क्या होगा? As a result, the resultant dipole will be in this way. This is resultant dipole. This is resultant dipole. So क्या आ रहा है मोलिक्यूल में? डाइपोल मोमेंट आ रहा है. So म्यू वैल्यू कितना आता है एमोनिया का? It is 1.47 divide. It is 1.47 divide. Next we can consider another molecule like H2S. यहाँ पे O की जगह पे हम लोग S ले लेंगे. मोलिकुलर फॉर्मूला है H2S. नाम क्या है? हाइड्रोजन सल्फाइड. So here also sulfur is more electronegative than hydrogen. So what will happen? It will draw the electron pair towards itself. Here also the same thing will happen. So as a result, we have resultant dipole in this way. The resultant dipole will be in this way, in this direction. So the mu value comes to be 0.90 divide. 0.90 divide. Okay, 0.90 divide. So ये हो रहा है जो हो रहा है. ठीक है. अभी एक मोलिक्यूल लेंगे हम लोग similar structure to NH3, similar molecular structure or similar structure arrangement of atoms in like NH3, that is NF3. So NF3 में क्या हो रहा है? ये यहाँ पे कुछ different situation create हो रहा है. कुछ different situation क्या हो रहा है? So क्या हो रहा है कि NF3. Okay. So NF3. So if we write here NF3. So this is nitrogen, this is fluorine, this is another fluorine, and this is another fluorine. Okay. So fluorine is more electronegative than hydrogen. Fluorine is more electronegative than hydrogen. So what it will do? It will draw the electron pair towards itself. Here also it will draw the electron pair towards itself, and here also it will draw the electron pair towards itself. As a result, fluorine becomes partial negative charge, fluorine acquires partial negative charge, and here also fluorine acquires partial negative charge. अभी क्या है? नाइट्रोजन में पार्शियल पॉजिटिव चार्ज डेवलप हो रहा है. पार्शियल पॉजिटिव चार्ज डेवलप हो रहा है। सो क्या हो रहा है? सो the resultant dipole in this, it will be in this way. Resultant dipole will be in this way. Why? इलेक्ट्रॉन ड्रॉ हो रहा है नीचे की तरफ से और रिजल्टेंट डाइपोल ऊपर की तरफ से क्यों है? क्योंकि as fluorine is electronegative, similarly nitrogen also is to some extent is electronegative. नाइट्रोजन भी किसी हद तक इलेक्ट्रोनेगेटिव है। सो ये क्या करेगा? नाइट्रोजन इट विल ड्रॉ द इलेक्ट्रॉन पेयर टुवर्ड्स इटसेल्फ। इट विल ड्रॉ द इलेक्ट्रॉन पेयर टुवर्ड्स इटसेल्फ। ओके, नाउ ये अगर ड्रॉ करेगा टुवर्ड्स इटसेल्फ, सो रिजल्टेंट डाइपोल विल बी समवेयर इन द मिडिल ऑफ रिजल्टेंट डाइपोल, इस रीजन में मंडराता रहेगा। এই রিজনে থাকবো রিজাল্টেন্ট ডাইপোল। ওকে, সো what will happen? The resultant dipole will be in this way, and the mu value comes out to be, dipole moment comes out to be 0.24 dBi, which is less than that of NH3, which is less than that of NH3। अभी एक एनसीईआरटी क्वेश्चन है, तुम लोग लिख सकते हो कि in NH3 and NF3 molecules, out of NH3 and NF3 molecules, which has higher dipole moment and why? Which has higher dipole moment and why? आंसर क्या है? इसका आंसर ये है कि in ammonia, in NH3, the bond dipoles point towards the nitrogen. The bond dipoles to point towards the nitrogen atom, whereas in NF3, these are directed away from nitrogen. These are directed away from nitrogen. As a result of this, what happened? Dipole moment of ammonia becomes more than that of dipole moment of NF3. That is, we can say dipole moment of NH3 is greater than that of dipole moment of NF3. Okay. अभी और एक टाइप ऑफ पोलिएटोमिक मॉलिक्यूल्स लेंगे। सपोज अभी लेंगे ये मॉलिक्यूल, सपोज इसको मिटा देते हैं हम लोग। So to compare I am keeping this one. So अभी लेंगे क्या? ये भी एक पोलिएटोमिक मॉलिक्यूल्स है, ये भी एक पोलिएटोमिक मॉलिक्यूल है। ओके, नाउ व्हाट हैपेंस? These polyatomic molecules and these polyatomic molecules have got a difference between them. ये polyatomic molecules और ये polyatomic molecules में एक बहुत बड़ा डिफरेंस है। क्या डिफरेंस है? अगर इस मॉलिक्यूल को हम बीच में से काटें, तो दोनों साइड उसका सेम है। Whereas अगर इस मॉलिक्यूल को हम बीच में से काटें तो उसका दोनों साइड सेम नहीं है, क्योंकि इसका नीचे की तरफ है 2 हाइड्रोजन, ऊपर की तरफ कुछ नहीं है। यहाँ पे अगर काटे कार्बन की बीच में से काटे तो वी हैव यहाँ पे लेफ्ट साइड में ऑक्सीजन, डबल बॉन्ड ऑक्सीजन, and then also in the right side double bond oxygen. So this molecule, this is a polyatomic molecule, this is also a polyatomic molecule, but the thing is that this is called as unsymmetrical molecule. This is called as unsymmetrical molecule, whereas this is called as symmetrical molecule. This is called as symmetrical molecule. Okay, so this is also a polyatomic molecules having polarity. This is also a polyatomic molecules having polarity. Abhi now we will consider symmetrical polyatomic molecules. What happens with symmetrical polyatomic molecules? तो देखते हैं क्या होता है। Okay, let's see. चलो बच्चों इसको देखते हैं क्या होता है। So let us consider CO molecule. Okay, CO molecule. Okay, now what happens? Oxygen is more electronegative than carbon. So it will draw electron pair towards itself. Similarly here also oxygen is more electronegative than carbon, so it will draw electron pair towards itself. So क्या होता है? ऑक्सीजन में डेल माइनस चार्ज आएगा, यहाँ पे भी डेल माइनस चार्ज आएगा और कार्बन में आएगा डेल प्लस चार्ज। सो यहाँ से इस तरफ से ऑक्सीजन खींच रहा है इलेक्ट्रॉन, यहाँ से भी ऑक्सीजन खींच रहा है इलेक्ट्रॉन। सो रिजल्टेंट डाइपोल अराउंड कार्बन के आसपास रिजल्टेंट डाइपोल क्या होगा? 0 हो जाएगा, क्योंकि मेरा लास्ट क्लास में मैं भी बोला था, सपोज ये यहाँ पे एक आदमी है, इसको एक आदमी यहाँ से खींच रहा है और एक आदमी यहाँ से खींच रहा है, दोनों आदमी का पावर सेम है, दोनों आदमी का पावर सेम है। ओके, सो एज ए रिजल्ट क्या होगा, इस आदमी का रिजल्टेंट डिस्प्लेसमेंट विल बी 0। वो आदमी जितना तक दूर तक हो वहां तक जाएगा, इतना दूर तक राइट साइड में भी जाएगा। सो रिजल्टेंट डिस्प्लेसमेंट ऑफ दैट पर्सन विल बी 0। सो what happens here also same case, oxygen is electronegative, so it is drawing electron towards itself, and that way also oxygen is there, it is also electronegative, it will also draw electron towards itself। so as a result क्या होगा, यहाँ पे रिजल्टेंट डाइपोल क्या होगा, इस रीजन पे 0 हो जाएगा। सो डाइपोल मोमेंट विल कम एज 0 डिवाइड। ओके, now let us consider another polyatomic molecules. This is symmetrical polyatomic molecule, CCl4, CCl4। ओके, तो क्या होगा, ये Cl is more electronegative than carbon, so it will draw electron pair towards itself। Here also it will draw electron pair towards itself, here also it will draw electron pair towards itself, and here also it will draw electron pair towards itself। so what happens, इस रीजन पे रिजल्टेंट डाइपोल क्या होगा, सो ये हो जाएगा डेल प्लस, ये हो जाएगा डेल माइनस, डेल माइनस, डेल माइनस, एंड हियर आल्सो डेल माइनस। सो इस रीजन पे रिजल्टेंट डाइपोल क्या होगा, 0 हो जाएगा, क्या होगा, 0 डिवाइड हो जाएगा। ओके, so in CCl4 molecule also we have got dipole moment value as 0 divide। okay, so this is what happens with symmetrical polyatomic molecules, क्योंकि ये मोलिक्यूल सिमेट्रिकल क्यों है, क्योंकि अगर इसमें हम बीच में से काटे तो दोनों साइड सेम है, ये भी अगर बीच में से काटे तो यहाँ पे भी ऊपर भी Cl है, नीचे भी Cl है। अगर ये यहाँ से काटे तो एक सेल यहाँ पे है, एक सेल ऊपर में है। अगर यहाँ से काटे तो एक सेल यहाँ पे है, यहाँ पे भी एक सेल है। अगर ऐसा काटे तो एक सेल नीचे है, एक सेल ऊपर है। सो दोनों बोथ ऑल द केसेस में क्या हो रहा है, ये सिमेट्रिकल मॉलिक्यूल्स हो रहा है, ये सिमेट्रिकल मॉलिक्यूल्स हो रहा है। ओके, so that is why we have seen that symmetrical polyatomic molecules have 0 dipole moment। Similarly, let us consider another case, BF3 molecule। You have heard the name, तुम लोगों ने नाम सुना होगा BF3 molecule का, डेफिनेटली तुम लोगों ने सुना है। So this is BF3 molecules। okay, BF3 molecules। So fluorine atom is more electronegative than bromine, so it will draw electron pair towards itself। Here also it will draw electron pair towards itself, and here also it will draw electron pair towards itself। As a result, fluorine will acquire negative charge, partial negative charge। Here also fluorine will acquire partial negative charge, and here also fluorine will acquire partial negative charge। So क्या हो रहा है, इस तरफ से भी खींच रहा है, इस तरफ से भी खींच रहा है, नीचे की तरफ से भी खींच रहा है। सपोज तुम लोग मान लो बोरॉन जो है वो एक तुम्हारा टेबल है, बोरॉन के ऊपर में, टेबल के ऊपर में F है, टेबल के नीचे में भी F है। सो दोनों तरफ से खींच रहा है, इलेक्ट्रॉन खींच रहा है। सो एज ए रिजल्ट क्या होगा, सो दोनों तरफ से इलेक्ट्रॉन खींच रहा है तो एज ए रिजल्ट क्या होगा, नेट डाइपोल मोमेंट, रिजल्टेंट डाइपोल अराउंड दिस। सो बोरॉन will acquire partial positive charge and this will all will acquire partial negative charge। so as a result क्या होगा, बोरॉन का इस रीजन पे resultant dipole moment will be equal to 0। resultant dipole moment will be equal to 0। and ये also is also an example of symmetrical polyatomic molecule, because if I cut over here, what happens, we will have एक फ्लोरीन नीचे, एक फ्लोरीन ऊपर, एक फ्लोरीन नीचे, एक फ्लोरीन ऊपर। that is why this is also an example of this symmetrical polyatomic molecules। okay, so what we have seen till our today's discussion, that we have discussed about diatomic molecules, how the dipole moment is coming in that diatomic molecules because of the electronegativity difference between the two atoms। then we have discussed the polyatomic molecules, unsymmetrical polyatomic molecules। okay, so unsymmetrical polyatomic molecules, we have seen that there is some dipole moment। for example, we have taken water, ammonia लिया हम लोगों ने, then H2S भी लिया और NF3 भी लिया। so देखा गया कि सभी मोलिक्यूल में कुछ ना कुछ डाइपोल मोमेंट वैल्यू आ रहा है। जैसे वाटर में आ रहा है 1.84 डिवाइड, Ammonia में आ रहा है 1.47 dB, whereas in NF3 it is coming as 0.24 dB. Here one question: out of NH3 and NF3, which has higher dipole moment and why? Which has higher dipole moment and why? So क्या होगा आंसर? In NH3 and NF3 and ammonia will have higher dipole moment because in ammonia the bond dipoles point towards the nitrogen atom, whereas in NF3 these are directed away from nitrogen atom. These are directed away from nitrogen atom. As a result dipole moment value decrease हो रहा है. As a result क्या हो रहा है? Dipole moment value जो है वो decrease हो रहा है. Okay. Next we have discussed about symmetrical polyatomic molecules. Symmetrical polyatomic molecules. Okay. Like CO2, CCl4, BF3, etc. Where if we cut the molecules from the center of the central atom, क्या होता है? ऊपर भी same type of atom है, नीचे भी same type of atom है. So both the sides are mirror image of the other. Both the sides are mirror image of the other. So क्या हो रहा है? कि this type of molecules they have net dipole moment is 0. Net dipole moment becomes 0 in this type of molecules. So this is what we have discussed, how we will measure the degree of polarity in a covalent molecule. Okay. So in my next class we will discuss what application does this concept have in covalent molecules. What application does this concept have in covalent molecules? So next we will discuss applications of dipole moment. So we are at the middle of this chapter. Very interesting things are coming out. So ये चैप्टर का नाम है केमिकल बॉन्डिंग. सो बॉन्ड जो है वो क्या कर रहा है? बॉन्ड सभी को मिलाता है. सो बॉन्ड एटम को भी मिलाता है. सो केमिकल बॉन्डिंग चैप्टर क्या है? बहुत ही इंटरेस्टिंग है. अभी हम लोग धीरे धीरे बीच में गहराई में जा रहे हैं. सो वी आर गोइंग टू द डेप्थ ऑफ द वेल. सो इट इज ए इंटरेस्टिंग चैप्टर. आई थिंक द स्टूडेंट्स must be enjoying it and enjoying my lecture also. So if there is any some technical problem, please neglect it. Okay. So I will try to give my best. So you people, what you have to do is just to study well. So with this I want to end up my lecture here today. Wish you all the best wishes. Thank you.